Hello. So you have completed the first phase of software engineering where the focus was more on requirement gathering and analysis. Now we will discuss the second phase, which is about software design, and we can design the software using different software architectures. So we will discuss those in this section. I am Dr. Ankit Chaudhary. I would be discussing different patterns and design issues, and we will see how we can improve the quality of a software with a better design. At this stage, you have seen how to gather requirements, how to analyze them, and document them in a document called SRS. In requirements, there are different requirements. Few are functional, few are non-functional, and it depends on the requirement engineer in how many ways or from different angles the requirement analysis can be done. Now there are two questions. One, why we need design? I know what is the problem, what the client is asking. We have gathered the requirement, and I can do the coding, I can implement what the client has asked. So what is design and why we need this? The second one, if we have the requirements, how we can convert those into the design? And then a follow-up question would be there. If we are making the design, how we can say that this is a good design? So we'll see them one by one. Let's see first why we need a design while I feel comfortable in coding the given requirements. So this is from the textbook freshman. A scenario is given that there are three teammates and they are discussing something about a product. Here, one teammate is suggesting that he can code everything what is needed and we don't need any design or any abstraction on that, while two other teammates are trying to convince Jamie that it would be better if we have the design and we can see in advance what things can happen, and we need not to go into minute details to see the problems. Coding is very time consuming and considered a costly work, so we probably should avoid the implementation at this stage and should focus on the design. So I would recommend everybody to read this conversation. A design is like a blueprint of the house. Let's say you want to make a house and you have something in mind that you need these many floors, and on each floor the structure should be like this, and you know everything about what kind of paint you want, what kind of floor you want. Now, when you are telling these things to the contractor may understand everything or may get like 80%. Wonderful. But are you sure that contractor has understood everything, or let's say 80%? So one way is that we can wait till the house is ready, and we can match whether it is as per your expectations or this is what you planned. Second way is we can make a blueprint according to some standard protocol which the contractor can understand well as there are chances of no error. Once we have the blueprint, you, the contractor, or any other person who will see the blueprint, they would be having the idea what kind of house they are going to make. After making the basic blueprint, later detailed design for minute things and extra things can be made and can be given to the contractor so that what you are planning in your mind about your house, the contractor is making the same thing. And when you are going to receive the house, when contractor has finished everything, you can verify that this is the design I gave to you, this is the blueprint I gave to you, and the house is as per the blueprint or not. If the house is as per the blueprint, this is what you wanted. So, doing an implementation without the design is quite risky, whether this is about the house or whether this is about the software. And if the cost of the implementation is quite big, we cannot take chances. So from the beginning, we have to make sure that the implementation is happening according to our requirement, and the person who is implementing, he or she is making this according to the designs, and designs are showing the requirements which they collected from the client. So design is a very important and very useful concept in the software engineering. Now, as we were discussing before, there are different requirements. Few clients will tell you, few you have to think from the domain, you have to make few assumptions about the implementation, and those assumptions should be in the abstraction, it should not be concrete. There should be room for further modification for the coder. So there may be a data design based on what kind of data the software would be storing or processing. There may be a procedural design, and there would be an architectural design. And this design is the basic blueprint which would be showing the connection among the different components of the software. And to show this, we have different patterns which are already defined in the software architecture theory. Few well-known patterns are MVC, Model View Controller, Blackboard, Client Server Model, Repository, and Pipe Filter Model. So these are few well-used models, and we will see that in a given domain where we have the requirements, which of the pattern will fit in our software design. There is no fixed rule that you should use this pattern in this domain, although according to the designer's view, according to the requirement and the functionality of the software, we will see that which pattern will fit in our design. Now, when we talk about design, there are few concepts that we will be discussing in this section. Many concepts you would be knowing from different subjects, while the use of these concepts in design may be different. We have discussed the architecture, which is like the blueprint of the house, and very important to understand the functioning of the software, the overall structure of the software, and this will make the software implementation an easy task or a hard task, depend on the design. Then we have patterns, as we were talking about few, which can be used to show the architecture of a given software. Then we have few concepts from the object-oriented approach given by Buch and Rumbach and Jacobson. Abstraction, where we try to hide few things from the user so that the details of the system or the software or the design to which user is not directly concerned or not directly using, we can put them in some envelope, like we make methods in object-oriented programming, and we give only a method call to the user, and we don't show what is inside the method because user is interested in the functionality, not in the details. And most of the APIs are like this, where just one call is given to the user. Then we have separation of concerns, where a big problem can be divided into different pieces, or two user or two agents, software agents, should be working separately, and they would not be interfering in the functionality or the usability of each other, and that will make the design and the implementation very smooth. Then we have modularity. As you would be knowing, the benefits of modularity. If we can have a software in different modules and or in a code, and we are interested in changing one module or one function or one behavior of the software, that we can do easily, because the module would be communicating with other modules with some connectors, and if we are bringing a new module while replacing the old one, the new module should communicate to older system with the same connectors. So if the communicating methods are same, the new behavior, the new module would easily fit in the system. I would like to show you one chart about modularity, that how number of modules can make an impact on the cost of the software. And I hope you know from the client's view that cost is one of the major factor in software building. So if you see on horizontal axis, we have number of modules which are increasing when we are going from 0 to infinity, and on vertical axis we have cost of effort. So if you see The green line here, when we have less number of modules, the cost is high, while as the number of module grows, the cost per module goes low. So that's a good news. Does it mean that I can have as many modules I wish? Can I have 70,000 modules in a software? Let's see. If you see this red line, if we have number of modules low, the cost to integrate is low, and here if number of modules are high, the cost to integrate is very high. So having a high number of modules is not very cost effective. Having low number of modules also not very cost effective. So we should go with a range of number of modules, and those are shown here between these two blue lines, and this is the area where cost per module and cost to integrate both are minimum. Also, the total cost of the software would be minimum in this range. So if we go little this side of the blue line or little right side of the blue line, that would be okay. But if you go very far off the blue line or very far right of the blue line, that would lead to the high cost of the software. Next one is information hiding, which is again an OOP concept. Information hiding is quite important and useful concept, and we will use it heavily in different designs. Functional independence, where the design, or let's say a class or a piece of software, should focus on one thing. We call this as low coupling and highly cohesive design. This is to avoid dependency on other part of the software, as well as the functions or the behavior which are similar, they will come together with functional independence. Refinement. As we go for different versions of software requirement analysis, similarly we go for different design and later on detailed design to add more and more information in the diagrams, so that the person who is going to implement the system, the software, the person would be having more information about the concept and about the thinking of the designer. It is assumed that if there are 10 coders who are going to implement the software, the design should be like this, that all of them should interpret the design unambiguously. So there should be a one-to-one mapping from the design to the code. We have few other concepts like refactoring, which is about simplifying the software as per the organization need, and different object-oriented and classes designs. The Important one is aspects where we have to think that how global requirements and some non-functional requirements can impact the design and how we should accommodate those things so that our design can sustain in ever-changing markets and can fulfill the requirements of tomorrow. It has been seen that once a design was made and it was implemented, even after a decade, the same software was sold to different companies based on the same design, or minor changes were implemented in the software with the same design, and banking is a normal example of such market where the software sold 10 years back is still working in the market while only minor change has been done. So this diagram is one example of architectural model, and this has been implemented using MVC pattern, model view controller pattern. The components are shown, although the connectors are shown like arrow. As we discussed, there may be more than 50 such patterns. We will see few, and there are programming languages which can implement those architectural patterns, and these languages has been quite successful in the market. Acme and Rapide are such languages. So at this stage, I'm assuming that all of you know the UML, how to make class diagram, sequence diagram, data flow diagrams, and how to convert the code from a class diagram in an object-oriented language. Although I would not be discussing more about coding, but the implementation and the design are very close, and once we have the design, the programmer has to think from implementation view. So the design must have everything what a programmer will need during the implementation. Also, we can leave some space where the programmer can make some assumption if he or she needs according to the code requirement. So we will discuss more about design in the next class, and I suggest everybody to go through the textbook and read about design concepts and think from designer's point of view, not as a programmer, as the objective of the design is to have a clear understanding of the software, as well as the design should have the details for the programmer. If you have any question about today's discussion, you can email to me. Thank you.